Okay, so today we're going to continue our study of probability. Yesterday we looked at what probability is and how to calculate theoretical and experimental probability. So we know that probability is the likelihood that an event will occur. Okay? We identify that likelihood by calculating the ratio of favorable outcomes to total number of outcomes. Okay? We can represent that as a fraction, a decimal, or a percent. It does not matter. We just need to abide by whatever the question is asking us. We also talked about theoretical probability. What should happen when you flip a coin 200 times? What should happen when you pick a queen of hearts out of the deck 50 times, right? And we also talked about experimental probability. What actually happens when we perform that experiment? So when I flip my coin 50 times, how many heads did I get and how many tails did I get? So those are our main types of probability that we talked about yesterday. When we look at probability, there's single events, okay? So when we talk about single events, that means rolling a dice and trying to get a 3, okay? Flipping a coin and trying to get a yellow, trying to pull a diamond out of the deck. Okay, those are single events. So we only calculated probability of single events yesterday. Today we're going to look at outcomes of compound events. Okay, so compound events is when 2 or more events are occurring at the same time. And there's different ways that we can calculate or we can list the outcomes of compound events. So a compound event would be rolling a dice and flipping a coin. Okay, or flipping a coin and pulling a card out of a deck. Because 2 or more events are happening at once. We're going to look at creating tree diagrams, organized lists, and tables today that focus on calculating, or not calculating, but listing the outcomes of these compound events. So, our first problem, Haley has 2 sisters and no brothers. Josh has 2 brothers and no sisters. They wonder what the chances are in a family with 3 children that the children will be all boys or all girls. How can they determine all possible combinations of boys and girls in a family with 3 children? Okay, so I have 3 kids, right? I go girl, boy, boy. Okay, anyone else have 3 kids in the family?
Me, my brother, and my 2 other sisters.
Okay, so it goes,
Me.
no, what's the order?
Oh.
Girl, girl, boy, boy, right? Okay, so the Strouds go girl, girl, boy, boy. Okay, the Yeagers go boy, girl. Right? Anyone else?
Yeah,
What?
there's more.
Oh, there are?
Mm-hmm.
Are they younger or older?
Older.
Oh, okay, see, I missed. Okay, the Ellises go,
Girl, boy, boy.
yeah, girl, boy, boy, boy. The Parks, boy, then, what? Boy, girl, right? See, okay, Stempowski's go boy, girl, girl. Okay, so in the Winds you go girl, girl, boy, yes? Okay, so we have all these, different combinations of families. Okay? So when we look at this, we can actually list this in a tree diagram. Okay, so child 1. Okay, what are the possibilities of the genders of child 1? Boy and girl. Okay, and now I understand there's a lot of things that we can talk about outside of gender and things like that. We're just talking about at birth, correct? Okay, I am sensitive to it. I understand it. So this is just assigned at birth. Okay, so I don't mean to offend anyone. If I do, please let me know. All right, so child 1, boy or girl, correct? Okay, what about child 2? What are the options for child 2? Boy or girl. Okay, so when child 1 is born and it's a boy, child 2 is born, it could be a boy or a girl. Okay, so when the Oles, okay, Tyler, then Shane. So they went boy, boy, right?
Debatable.
Stop it. Zachary. Okay. Now, what about this one? First born is a girl. Second child can be a boy or girl. Okay, so our options so far are boy, 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 girl, girl, boy, or girl, girl. Okay, so like this is the Zadok's. We had girl, boy first, right? In my family, the Shocks, we had girl, girl first. Okay, and then the third child comes along. What are the options for the third child? Boy, girl, right? So boy, girl, boy, girl, boy, girl, boy, girl. So our options for having 3 children: boy, 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 girl, boy, girl, boy, boy, girl, girl. Okay. And then if we have a girl first, we go girl, boy, boy, girl, boy, girl, 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 boy, or girl, girl, girl. So how many options do we have? We have 8. There's 8 different combinations that could possibly happen if you have 3 children. Okay? So, how can they determine the possible combinations of boys and girls in a family with 3 children? We have a tree diagram. Okay? And there are 8 possible combinations. Correct? Okay. What?
Just making out loud, I'm guessing.
So that's a tree diagram. Okay? You start with the possible option or outcomes, and then you list the possible outcomes in a tree format. So again, there's 8 possible outcomes. Now, here's our next one. A game is played using a spinner shown, the spinners shown. So spinner A, we can spin a 1, 2, 3, 4, 5, or 6. And spinner B, we can spin a yellow, red, or brown. Okay. What are the possible outcomes? Okay. So when I'm looking at the possible outcomes, I can spin and get a 1, and then I can spin and get, right? I can spin and get a 1 and spin and get a, I can spin a 1 and get a, right? So another way we can do that, could we use a tree diagram for that?
Yes.
Yeah, because we could put 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6 at the top, and then red, yellow, brown, red, yellow, brown, red, yellow, brown, red, yellow, brown. We could also make a table. So when we make a table, we can list 1, 2, 3, 4. Oh, go gosh. That's fine. Come on, guys. You can laugh. It's all right. You can laugh at me. I kept on forgetting 10 yesterday when I was counting. So, it's just one of those things. Okay? So, this is spinner A. And then down here, what are we going to list here? Spinner B. Shane, wake up, babe. You okay?
Trey fell asleep in reading yesterday, and we were gonna pour water on his head, but Mrs. Figueroa said no.
Oh,
So I ended up just clapping in his ear.
oh, nice. So nice of you.
Yeah, very.
Good friends.
Children.
Great friends. Okay, so we can spin a 1 and a
Why?
yellow, right? So 1 and yellow. We can spin 2 and
Yellow.
3 and
Yellow.
4 and 5 and 6 and, right? So then we can spin a 1 and a
Red.
2 and a 3 and a. Can you finish the table? Okay, go ahead. How many total outcomes are there? 18 total outcomes, right? We've got 3 outcomes here, 6 outcomes here, so together we have 18 outcomes. What do you notice about the number of outcomes of each spinner and the total number of outcomes?
They're 1/3.
I don't think so. How many outcomes are on spinner A?
6.
Okay. How many outcomes are on spinner B?
3.
What do you notice about the number of outcomes on each spinner and the total possible outcomes? 6 times 3 equals 18. So the product of the outcomes, the product of the events, or the outcomes, is going to be your total possible outcomes. Does that work every time? Okay, well let's look here. How many possible outcomes were there for child 1?
2.
How many possible outcomes for child 2?
2.
How many possible outcomes for child 3?
2.
2 times 2?
4.
4 times 2?
8.
8 possible outcomes? This is called the counting principle. Right? And the counting principle, you can find the product of each event. You know, find the number in each event, and their products will give you the total possible outcomes. Okay. So, if I asked you to list the possible outcomes, I'm looking for a tree diagram, I'm looking for a table, I'm looking for an ordered list. Okay? You can actually calculate the total possible outcomes without having to do a tree diagram, a list, or a table. Okay? Just by multiplying the possible outcomes of each event. Okay? Spinner A is an event, spinner B is an event. So the outcomes of spinner A is 6, outcomes of spinner B, spinner. I'm gonna get fired one day. All right, just to let you know. It's all recorded now, it's fine. Outcomes of spinner A are 6, outcomes of spinner B, 3. So 6 times 3 is 18. I haven't changed though, have I, Savannah? No, see? I live to teach another year, it's fine. All right, so here's another example of a compound event. Rolling a dice, and then flipping a coin. Okay? How many possible outcomes are there on the dice? Or number cube? 6. How many possible outcomes are there on the coin?
2.
How many total possible outcomes are there going to be in the event?
12. Or 12.
What he said.
Is it 12 or is it 8?
It's 12. Don't listen
Okay.
to them.
So 6 possible outcomes on our number cube, 2 possible outcomes on our coin. So 6 times 2 equals 12. Okay? So we know, even before we start, there are 12 possible outcomes. So I flip a coin, and I get a heads. And then I roll a dice and I get a 1. What's the event? Heads and heads and 1. Okay? So I flipped my coin, I got a heads. I rolled my dice and I got a 1. What's another possible combination? Okay, we could go tails 1, yep. Very good.
Heads 2.
Heads 2.
Heads 3. Tails 2. Heads.
So heads and rolling a 1. Heads and I rolled a 2. Tails Heads rolled a 1. Tails rolled a 1. Heads rolled a 2. Tails rolled a 2. Okay? So this organized list gives you the possible outcomes of each event. And we know there should be how many possible outcomes?
12.
So again, tree diagram, table, or an organized list helps us to list the possible outcomes of the event. We can use the counting principle to determine how many possible outcomes there can be without listing the events. Okay, so I want you to go ahead and put your pencils down. Before we talk about that, your homework are these 3 problems. Okay, so this Oliver playing a game, someone wanted to purchase a new car, and then this bakery problem. 3 problems for homework tonight, okay? And those are on the back of your worksheet. We're going to take a detour. We're going to talk about Chipotle. Okay? So, when I lived by myself in Columbus, you're single, don't want to cook every night, right? So on Monday night, I would go to school all day. And then my passion really, I love to teach. I love to teach math. But what I really love to do is teach preschool gymnastics. Okay? You guys know I was a gymnast. We've talked about this before. But little kids, like that 3, 4, 5 age, and teaching them gymnastics, I loved it. So even though I worked full time, I found a gym when I lived in Columbus, and I only did on Monday nights. I did 3 preschool gymnastics classes, and it was like my outlet, right? Teaching math is kind of a lot of stress, because they put a lot of pressure on you for test scores and things like that, and kids hate math. So it's stressful. But these little kids doing preschool gymnastics, jumping from color to color and learning things, I loved it. So I would do that Monday night. My class started at 5. I was done by like 7:30. And I would go to Chipotle every Monday night. I'd get 3 tacos. I'd eat 2 tacos, and then I'd save 1 for lunch the next day, right? So I love Chipotle. I don't love it so much now for some reason. I was burnt out of it, but I know the Chipotle menu really well from going there every Monday for about 6 years, right? So let's talk about the possible combinations of ordering something at Chipotle. Are you ready?
No.
No? Okay. So, what do you start with, right? You roll up, you want to eat something.
Rice.
Okay, right? So that's the first thing we have to decide. Are we going to get a burrito? Are we going to get a bowl?
Tacos.
Are we going to get tacos? Are we going to get a salad? Okay. Or we're going to get a quesadilla, right? Is that it? I think that's it, right?
Yeah, now.
Okay. Now, what's the next question they ask?
What kind of rice?
What kind of rice do you want? What are the options?
Cauliflower, brown, and white.
Okay, so cauliflower, new addition, right? Brown rice, white rice. What if you're gluten-free?
Then you put cauliflower.
Can you have rice? So how many options are there?
Four.
Right? Okay. So we have cauliflower, brown, white,
No.
or none. And we need this in our bowl too, right? Okay. Let's clone that. Can we get rice in our tacos?
Yeah.
We could, right? If you're weird, just Can we get rice on our salad?
Yeah.
I guess so.
That's odd. Yeah, that's really odd.
Yeah. Can we get rice on our quesadilla?
Yeah.
Okay, we could. Again, weird, right? What's the next question they ask?
Any kind of meats.
What kind of protein do you want? Right? So we got chicken, steak, carnitas,
And then.
barbacoa, which is the spicy beef. Then you can get sofritos, which is like tofu.
And then you got
Or if you're vegetarian,
the fried vegetables or whatever those things are.
right? If you're vegetarian, do you get anything in there?
And then special.
Okay? So now, off of our burrito, then we get chicken, and we can get cauliflower rice. Then we have to use chicken, carnitas, barbacoa, steak, tofu, or none. So now we have 6 coming off of just cauliflower, and 6 coming off of brown rice, 6 coming off of white rice, 6 coming off of no rice. Is it possible to make a tree diagram of the options at Chipotle? It's possible,
Spend an hour and a half.
right? Are we going to, you are going to need a massive space to be able to do this, correct?
Yes.
This is where the counting principle comes in, okay? So let's retool, okay? So we have 1, 2, 3, 4, 5 options for the base. Do you know what I'm talking when I say the base of the meal?
Yeah.
Burrito, taco, bowl, all those. Okay, so we got 5 options, right? 1, 2, 3, 4 options for rice, correct?
Yep.
And then we say 6 options for protein?
Yeah, 6.
Okay, what's the next question?
Any kind of toppings.
Okay, so your add-ons. Fajita vegetables or
Beans.
no fajita vegetables, right?
Yeah.
Because some people like the peppers and the onions, some people don't. So there we've got how many options there? 2. Okay, and then we got to go to the beans. Okay, black beans, pinto beans, or
No beans.
no beans. So we've got,
3.
okay, then we got salsa.
Sour cream.
Okay, so when we go salsa, we've got corn, tomato, the medium salsa. I think there's 5.
Queso too? What's queso too?
No, that's not.
What do we think?
I just pulled every Thursday.
Corn, the pico de gallo, which is like the fresh tomato.
Yeah.
Then you've got the spicy red.
Yeah.
Then is there green too?
Yeah. Guacamole.
And is there, we're just on salsas. And then what if you don't like salsa?
No sauce. No.
5, right?
Don't forget the special water.
Okay. Then we can get sour cream or, no, sour cream or no sour cream. Guacamole or cheese or queso or lettuce or right? So, do you see why Chipotle is so successful? Because there's so many different options, okay? So we've got 20 times 12, 20 times 12 times 15 times 4 times 4 times 2. Okay? So, okay, this is how many different possible combinations right now that Chipotle can make for you.
So back to drawing the line.
Okay, so do you see why this does not work in this situation? But then here, the counting principle works for us, right?
115.
Okay? What we're not considering at all, when I order tacos, I can get flour, corn, or hard shells. So I've got an additional 3 options. I can get double chicken, double beef, double barbacoa, double carnitas. I can get chicken and beef, chicken and barbacoa. Do you see? There's so many different options if you then want to go double the meat. Right? I didn't even talk about, I like corn and the fresh tomato salsa. So that's another combination. Okay? So, yeah, this is just basic right here. But that's why a tree diagram always, or a table or an organized list doesn't always work for us. Now, there are, obviously, we know, over 100,000 just basic combinations at Chipotle. There are probably over 1 million different combinations at Chipotle if you actually think of all the different things that you can add and subtract with your meal. Okay, then you gotta talk about chips. You can talk about drinks. It's endless, right? So this is, listing our different outcomes of compound events. We do have some limitations of listing listing the possible outcomes, but we can always calculate the total possible outcomes by using the counting principle, and that is multiplying the number of outcomes on each event to get our total number of outcomes. Okay? When you go through Chipotle, would you imagine that there were 115,200 combinations?
Yes.
Just basic combinations? No, you probably, oh man, there's like 50 ways you can order things at Chipotle. No. Right? Subway is even worse. You know what I mean? Because you got all different kinds of breads, you got different kinds of meat, different kinds of vegetables. Different sizes. Subway's even worse. But again, think about how successful Subway is and Chipotle is. Okay, because they've got so many, they can reach so many different customers. Okay? All right, so your homework tonight, those 3 problems.
That was fun.
That's it.